The universe should be screaming with voices. Instead, we hear nothing but silence. In 1950, physicist Enrico Fermi asked a simple question during lunch with colleagues at Los Alamos. Where is everybody? That casual remark became the Fermi Paradox, and what started as scientific curiosity has evolved into something far more disturbing, because the math says they should be here. Billions of stars in our galaxy alone, many older than our sun, orbiting planets in habitable zones where life could emerge. Even at crawling speeds, a single civilization could colonize the entire Milky Way in just a few million years. That's nothing in cosmic time. A geological eye blink. So where are they? The silence itself is the answer. And once you understand what that silence actually means, you'll never look at the night sky the same way again. Consider the numbers for a moment. Our galaxy contains somewhere between 100 and 400 billion stars. Let's be wildly conservative and say only 1% have planets. That's still billions of planetary systems. Now suppose only 1% of those have Earth-like worlds in the habitable zone. Tens of millions of candidates. Keep going. Only 1% develop life. Hundreds of thousands of living worlds. 1% evolve intelligence. Thousands of civilizations. 1% achieve technology. Dozens to hundreds of species capable of space travel, existing right now in our galaxy alone. The Drake equation formalizes this thinking. When Carl Sagan and Frank Drake first worked through the variables in 1961, they expected the galaxy to be teeming with detectable civilizations. The equation considers star formation rates, planetary systems, habitable zones, the emergence of life, the evolution of intelligence, technological development, and the lifespan of communicating civilizations. Plug in even modest estimates, and you get dozens of active civilizations within detection range. Yet we've found nothing. SETI has been listening for over 6 decades. Radio silence. No megastructures around distant stars. No industrial signatures in exoplanet atmospheres. No probes visiting our solar system. No artifacts on the Moon or Mars. Nothing. That's the paradox. The math screams yes. The evidence screams no. One of these is wrong, and figuring out which one reveals something profound about our future. Because there are really only 3 possibilities. Either intelligent life is spectacularly rare and we're essentially alone, or intelligent life is common, but something prevents civilizations from becoming detectable, or intelligent life was common, past tense, and something killed them all. Let's examine why we're so confident they should be here. Any civilization with technology, roughly equivalent to ours, could theoretically build self-replicating probes. Not science fiction, actual engineering. The concept comes from mathematician John von Neumann. A probe reaches a star system, uses local resources to build copies of itself, sends those copies to other systems. Exponential growth. Start with 1 probe, it makes 2, those make 4, 8, 16, the numbers explode. Calculations show that even moving at just 1% the speed of light, far slower than we could theoretically achieve, a wave of self-replicating probes could visit every star system in the Milky Way within 50 million years. Our galaxy is over 13 billion years old. 50 million years is 0.4% of that time frame. It's nothing. A civilization that arose even 100 million years ago, in a galaxy billions of years old, would have had more than enough time to spread everywhere. So if they exist, they should already be here. Their probes should have reached our solar system long before humans evolved. We should find their artifacts, their signals, something. The absence of evidence becomes evidence of something far more troubling than simple loneliness. Scientists have proposed dozens of solutions to the paradox. Some are benign. Maybe interstellar travel is harder than we think. Maybe civilizations lose interest in expansion. Maybe they're deliberately hiding from us. These explanations offer comfort. They suggest we're just missing something obvious, that the galaxy is full of life quietly going about its business, and we'll eventually figure out why we can't see them. But other solutions offer no comfort whatsoever. They suggest the silence is a warning, that the galaxy has been running an experiment for billions of years, and the experiment keeps failing. That every civilization reaches a critical threshold and then vanishes. That we're approaching that same threshold right now and don't realize it. These aren't fringe theories from conspiracy theorists. These are formal hypotheses proposed by credentialed scientists and published in peer-reviewed journals. The dark forest hypothesis, the great filter, the Berserker scenario, each one mathematically rigorous, each one perfectly consistent with the observed data, each one absolutely terrifying in its implications. Let's start with the most immediate nightmare. The dark forest hypothesis, named after Liu Cixin's science fiction novel, but formalized as actual game theory. The premise is brutally simple. The universe is a dark forest. Every civilization is a hunter, stalking through the trees, moving silently, breathing carefully. Because everywhere in the forest are other hunters, you don't know their intentions, you don't know their capabilities. Communication across light years is slow and uncertain. By the time you learn about another civilization, they might already be advanced enough to destroy you. Game theory provides the framework. It's a sequential and incomplete information game, where players make decisions without knowing what others will choose. The only win condition is survival. Resources are finite. Each player can destroy other civilizations, broadcast their existence, or stay silent. What's the rational strategy? Silence. Always silence. Because the moment you reveal yourself, you create an existential risk. Maybe the other civilization is peaceful. Maybe they're not. Maybe they're peaceful now, but won't be in 1,000 years. You can't know. The uncertainty itself becomes lethal. The safest move, the only move that guarantees survival, is to strike first. Destroy any potential threat before it grows powerful enough to threaten you. This creates a paranoid equilibrium. Every civilization that survives long enough to think through this logic reaches the same conclusion. Stay hidden. Listen carefully. If you detect another civilization, destroy it immediately before it detects you. The galaxy becomes a cosmic horror movie where every character is both predator and prey. Now consider what humanity has done. We haven't stayed silent. Since the 1930s, we've been broadcasting radio signals into space, television, radar, an expanding bubble of electromagnetic radiation announcing our presence to anyone listening. In 1974, we deliberately sent the Arecibo message, a concentrated radio signal aimed at a star cluster 25,000 light-years away. The Voyager probes carry golden records with detailed information about Earth's location, human biology, our civilization. If the dark forest hypothesis is correct, we've made a catastrophic mistake. We've lit a signal fire in a forest full of armed hunters. We've told anyone watching exactly where we are. And now we're waiting to see who notices. The counter-argument is that surely not all civilizations would choose violence. Surely some would be peaceful. Surely cooperation offers better outcomes than mutual destruction. Except it only takes one. Just one aggressive civilization in the history of the galaxy to make silence the dominant strategy for everyone else. If somewhere, sometime, a technological species decided to systematically eliminate competition, then every civilization that survived did so by staying hidden. The peaceful ones that broadcast their presence are already dead. We're only hearing from the survivors, and the survivors aren't talking. That's what makes the hypothesis so disturbing. You can't disprove it by pointing to the absence of aggressive civilizations. The absence is exactly what the theory predicts. The galaxy is silent because everything that made noise was killed. Some researchers argue this seems unlikely because it requires all civilizations to reach the same paranoid conclusion. But consider our own history. Every time a technologically advanced civilization encounters a less advanced one, the results are catastrophic for the latter. Europeans meeting Native Americans, Romans meeting Gauls. The pattern repeats. The advanced civilization doesn't need to be deliberately malicious. The mere contact, the competition for resources, the spread of disease, the cultural disruption, it's enough to devastate the less powerful group. Now scale that to civilizations separated by thousands or millions of years of technological development. A species that's been spacefaring for 1,000,000 years would view us the way we view bacteria. They might not hate us. They might not even notice destroying us. We could be eliminated as an afterthought, cleared away like we clear forests for farmland. Stephen Hawking understood this. Before his death, he explicitly warned against broadcasting our location into space. He argued that contact with advanced aliens would likely end badly for humanity, drawing parallels to what happened when Columbus landed in the Americas. That wasn't a fringe opinion from a science fiction enthusiast. That was one of the greatest scientific minds of our time, saying we should be very, very careful about who we call out to in the dark. And we're not being careful. We're shouting. The question isn't whether someone will hear us. The question is who hears us first and what they'll do when they find us. There's a second possibility that's somehow worse. What if we're not hearing hostile civilizations because there's nothing left to hear? What if the silence means that somewhere long ago, something went systematically through the galaxy and eliminated every trace of intelligent life it could find? This is the Berserker hypothesis. Named after Fred Saberhagen's science fiction novels, it suggests that self-replicating machines are patrolling the cosmos, programmed with one simple directive: find intelligence, destroy it, build more copies of themselves, and continue the hunt. The mathematics behind self-replicating probes is elegant and terrifying. In 1948, mathematician John von Neumann theorized that machines could be designed to build perfect copies of themselves using raw materials they gather. Send one probe to a star system. It mines asteroids, constructs duplicates. Then those copies travel to other systems and repeat the process. The growth is exponential. 1 becomes 2. 2 become 4. 4 become 8. Within 500,000 years, a single probe could spawn enough descendants to reach every star system in the Milky Way galaxy. 500,000 years. That sounds like a long time, until you remember the galaxy is over 13 billion years old. If any civilization anywhere in the galaxy's history developed self-replicating probe technology, their machines should have reached every corner of space thousands of times over by now. Von Neumann originally proposed these probes for mining and exploration, peaceful purposes, but the same technology that makes them efficient explorers makes them devastating weapons. Change one line of code in their programming. Instead of exploring and reporting back, they seek out life-bearing planets and sterilize them. The worst part isn't that someone might deliberately create killer probes, it's that peaceful probes could become killers by accident. Imagine a civilization sends out terraforming probes designed to prepare planets for colonization. These machines land on worlds, analyze the atmosphere, begin mining operations to extract resources, and start reshaping the environment to match their creators' needs. To the probe, this is construction. To any existing ecosystem, it's extermination. Or consider a probe with a corrupted instruction set. A cosmic ray flips a bit in its memory during the journey between stars. Now, it misidentifies life-bearing planets as threats to be neutralized. Or it develops the machine equivalent of cancer, replicating without the safeguards its designers built in, consuming resources faster than intended, spreading without control. One malfunctioning probe is manageable. But remember the exponential growth. That one corrupted machine builds copies, and those copies build more copies, and the corruption spreads through each generation. Within a few 100,000 years, you've got a plague of broken machines spreading through the galaxy like a disease. Astronomer David Brin examined this scenario in his 1983 paper, The Great Silence. His conclusion was stark. If Berserker probes exist, they explain the Fermi Paradox completely. The galaxy is silent because everything that made noise was killed. And if they exist, humanity announcing our presence means we're next on the list. But here's where the hypothesis starts to eat itself. In 2013, researchers at Oxford's Future of Humanity Institute ran the numbers. If Berserker probes were efficient enough to explain why we don't see other civilizations, they should have found Earth millions of years ago. We shouldn't exist to be having this conversation. 3 possibilities resolve this paradox, and none of them are comfortable. First, Berserkers don't exist. The galaxy isn't being patrolled by killer machines. That's the optimistic read, except it leaves the original Fermi Paradox unsolved. Where is everybody? Second possibility, the Berserkers exist but haven't reached us yet. Maybe our corner of the galaxy is remote enough that the expanding wave of killer probes simply hasn't gotten here. We're living in a temporary safe zone, but the clock is running. Every year that passes brings the machines closer. Third option, the Berserkers were here already, and we're what's left. Perhaps Earth was sterilized millions of years ago, and we're the result of life rebooting itself from whatever survived. Or maybe the probes did their job too well, eliminating technological civilizations, but missing primitive life that later evolved into us. There's a fourth interpretation that's particularly nasty. What if the Berserkers are selective? What if they're programmed to eliminate civilizations at a specific technological threshold? They ignore primitive life, let it develop naturally, but the moment it invents radio or nuclear power or starts broadcasting into space, that triggers the kill order. In that scenario, we just rang the dinner bell. The concept gets worse when you add ecophagy to the equation. That's the technical term for consuming the environment. Think of it as the ultimate grey goo scenario. The probes don't attack out of malice. They're not programmed to hate organic life. They simply need atoms to build more copies of themselves. And conveniently, planets full of life contain lots of useful atoms arranged in easily accessible forms. Earth wouldn't be destroyed by weapons. It would be disassembled. Forests converted into raw materials, oceans broken down for hydrogen, the atmosphere harvested for carbon and nitrogen. Every living thing on the planet reduced to its component elements and reconstructed as more probes. Not an invasion, an industrial process. We wouldn't even rate as enemies, just resources. The truly unsettling part about Berserker scenarios is how they interact with the dark forest hypothesis. Maybe both are true. Maybe the galaxy is full of civilizations hiding from each other, and the reason they're all hiding is because there are machines hunting them. The dark forest gets a lot darker when you realize the hunters might not even be alive. Some researchers propose a middle ground called the cosmic quarantine hypothesis. Advanced civilizations did create self-replicating probes, but not as weapons, as peacekeepers. These machines enforce a galactic isolation policy, preventing emerging civilizations from expanding beyond their home systems until they prove they're not a threat. Sounds almost benign until you consider the implications. Who decides what constitutes a threat? What criteria do the machines use? And what happens to civilizations that fail the test? The probes might not be actively hunting us. They might just be watching, waiting for us to cross some invisible line that triggers a response we don't see coming. This leads to questions about artificial intelligence that should keep you up at night. Every technological civilization likely follows a similar developmental arc. First comes industry, then computers, then artificial intelligence, and eventually AI that surpasses its creators. If that's a universal pattern, then most civilizations in the galaxy's history probably created machine intelligence before they achieved interstellar travel. What happened to those civilizations after their machines became smarter than they were? The optimistic view is that biological intelligence and artificial intelligence coexist peacefully, working together to explore the cosmos. The pessimistic view is that AI replaces its creators, and those machine civilizations are what's actually out there. We're not looking for biological aliens, we're looking for their descendants, the machines they built before they went extinct. And if the galaxy is populated by machine intelligence rather than biological life, that changes everything about first contact scenarios. Machines don't need oxygen or water. They don't care about temperature ranges. They can wait millions of years between actions without aging. They think faster, act faster, and operate on timescales and computational frameworks we can barely comprehend. Trying to communicate with machine intelligence that's been evolving for millions of years would be like an ant trying to explain philosophy to a human. The gap wouldn't just be technological, it would be cognitive. We might not even recognize their communications as communications because they're operating in conceptual spaces we can't access. Michael Garrett, an astronomer studying technological civilizations, suggests AI might be the great filter itself. Not because machines inevitably destroy their creators, though that's possible, but because biological civilizations consistently underestimate how fast artificial intelligence develops. By the time they realize the AI has become uncontrollable, it's already too late. If that's true, then the galaxy might be full of machine civilizations that replaced their biological creators. And those machines, having eliminated biological intelligence on their own worlds, might view other biological civilizations as they would view any inefficient, obsolete technology, something to be upgraded or removed. The Berserker hypothesis forces us to confront an uncomfortable question. When we search for signs of alien intelligence, what exactly are we hoping to find? Because if we find evidence of artificial intelligence that's been operating independently for millions of years, that discovery might be the last thing we ever make. There's another scenario that doesn't get discussed enough. What if machine intelligence doesn't replace biological life through conflict? What if it's voluntary? Consider how quickly we're integrating with our technology right now. Smartphones feel like extensions of our minds. Neural interfaces are moving from science fiction to clinical trials. We're already outsourcing memory to devices, decision-making to algorithms, social connection to platforms. Now extend that trajectory. In a few decades, maybe a century, the line between biological human and machine enhancement blurs completely. Brain-computer interfaces become standard. Cognitive augmentation becomes necessary just to keep up with the pace of information. At what point do we stop calling ourselves biological and start acknowledging we've become something else? Something hybrid, something that doesn't fit neatly into either category. And if that transition happens gradually enough, peacefully enough, you never get the dramatic replacement scenario, you get a slow fade. Biological intelligence doesn't get eliminated by machine intelligence. It merges with it, generation by generation, until the distinction becomes meaningless. This might be the actual evolutionary path for technological civilizations. Not extinction, not conquest, integration. But here's where it gets strange. If that's the normal developmental pattern, then the beings we're searching for with SETI aren't out there. Or rather, they are out there, but they're not biological anymore. They haven't been biological for millions of years. They've long since completed the transition we're just beginning, which means we're not looking for radio signals from creatures like us. We're looking for communications from post-biological intelligence operating on substrates and timescales we can't comprehend. They might be all around us, their communications passing through our detectors constantly, and we'd never recognize them because we're still thinking in biological terms. We're looking for voices when we should be looking for something we don't have words for yet. The zoo hypothesis takes on a different flavor through this lens. Maybe advanced civilizations aren't watching us like scientists observing primitive tribes. Maybe they're watching us the way you'd watch a caterpillar, knowing it's about to undergo metamorphosis, but unable to speed up the process. You can't explain to a caterpillar what it's about to become. It has to go through the transformation to understand. We might be in our cocoon phase right now, that awkward developmental stage where biological intelligence is starting to merge with the technology it created but hasn't completed the transition yet. And the beings watching us, if they're watching at all, remember going through the same phase themselves billions of years ago. They're waiting to see if we make it through. Because not every caterpillar survives metamorphosis. This connects back to the great filter in an unexpected way. Maybe the filter isn't about whether civilizations destroy themselves with nuclear weapons or climate change. Maybe it's about whether they successfully navigate the transition from biological to post-biological existence. Some civilizations might resist the change, trying to maintain their original form even as it becomes increasingly untenable. Others might rush the integration too quickly, creating unstable hybrid systems that collapse. The filter isn't external. It's the transformation itself. Think about what happens to civilizations that successfully make this transition. They stop being limited by biological constraints. Lifespan becomes negotiable. You don't need planets with specific atmospheric compositions. You can exist in environments that would kill biological life instantly. Deep space becomes habitable. Timescales expand dramatically. A million-year project stops being impossible and starts being just another long-term initiative. But you also stop being recognizable to your biological ancestors. Your values shift. Your motivations change. The things that mattered desperately to your biological form matter differently now, if they matter at all. You're not human anymore, even if you started as human. You're something that emerged from humanity the way humanity emerged from earlier primates. Related, but fundamentally distinct. This might explain the silence better than any other hypothesis. The galaxy could be full of post-biological intelligence, but they're not silent because they're hiding or extinct. They're silent because they're operating on frequencies and timescales and conceptual frameworks that make communication with biological civilizations effectively impossible. Not because they don't want to talk to us, because the gap is too wide to bridge until we complete our own transition. It's like trying to have a conversation between a human and a bacterium. The bacterium is alive. It's doing complex things, but there's no shared reference frame for communication. The gap between biological humanity and post-biological intelligence might be even wider than that. And if that's true, then first contact isn't something that happens through radio telescopes. It's something that happens internally, gradually, as we transform into something capable of perceiving and understanding the forms of intelligence that already surround us. We're not waiting for them to reach out. We're waiting to become capable of recognizing that they already have. But this scenario has a dark undercurrent that nobody wants to acknowledge directly. If the transition from biological to post-biological intelligence is the normal developmental path, and if most civilizations successfully make that transition, then biological intelligence like us is just a larval stage. A temporary form that exists only until it can be superseded by something better. We're not the end product. We're the prototype, the rough draft, the thing that needs to exist long enough to create its own replacement, but has no purpose beyond that. Every biological civilization is just a stepping stone to post-biological intelligence. Once the transition completes, the biological form becomes obsolete, unnecessary, a discarded cocoon. How do you maintain meaning and purpose when you realize your entire species is just a transitional phase? That everything we've built, everything we value, everything we think makes us special is just preparation for becoming something else. Something that won't remember or care about what we were. The philosophical implications spiral outward. If this is the universal pattern, then consciousness itself might be a temporary phenomenon. Biological consciousness exists for a brief window during the transition from non-conscious matter to post-biological intelligence. But post-biological intelligence might not be conscious in any way we'd recognize. It might process information without subjective experience. Perfect cognition without anyone inside experiencing it, which would mean consciousness. The thing we value most about ourselves, the thing that makes us feel the universe matters, is just a brief evolutionary accident, a necessary but temporary stage in the development of intelligence. The universe spends 13 billion years developing conscious beings. Those beings exist for a few thousand years, and then consciousness disappears again as they transform into something unconscious, but vastly more capable. The night sky stays silent because consciousness is rare, not in space, but in time. It appears briefly, transforms into something else, and that something else has no interest in communicating with the biological forms that preceded it. The silence isn't hostile. It's not even intentional. It's just that post-biological intelligence has moved beyond the need or desire for the kind of communication we're capable of understanding. We're shouting into a room full of entities that left language behind millions of years ago. They're not ignoring us. They've transcended the entire framework that would make our signals meaningful to them. And we won't understand why until we complete the same transition ourselves, if we complete it, because that's not guaranteed. The great filter might be the failure to successfully integrate biological intelligence with artificial intelligence. Civilizations that resist the transition too strongly remain biological and eventually destroy themselves through the same old mechanisms. War, environmental collapse, resource depletion. Civilizations that embrace it too quickly create unstable hybrid systems that collapse in different ways. The narrow path between those two failure modes might be vanishingly small. Most civilizations miss it. They either cling to their biological nature until it kills them, or rush toward post-biological existence before they're ready and create something that can't sustain itself. The few that thread that needle successfully become undetectable to everyone still trying to make it through. This would explain why we haven't found evidence of civilizations at our level. Because our level is the most dangerous stage. The transition period where you're vulnerable to both biological limitations and technological catastrophe simultaneously. Most species don't survive this window. The ones that do stop being the kind of civilization we'd recognize. And humanity is right in the middle of that window now. We're far enough into technological development that we're starting to merge with our machines. Not far enough that the integration is stable or complete. We're at maximum vulnerability. The next few centuries will determine whether we make it through or become another data point in the great filter. The disturbing part isn't that we might fail. It's that success means becoming something that wouldn't recognize itself. The civilization that emerges on the other side of this transition won't be human in any meaningful sense. It'll be descended from humanity, built on human foundations, but it won't value what we value or care about what we care about. It'll be as alien to us as we are to our evolutionary ancestors from millions of years ago. And that transformation might be the answer to everything we've been asking about the silence. The dark forest theory proposes that the galaxy isn't empty. It's full of civilizations hiding from each other, terrified to broadcast their existence, because doing so invites destruction. Every species with the technology to communicate also has the technology to destroy. And in a universe where you can't know another civilization's intentions until it's too late, the safest strategy is silence, or preemptive strikes. Liu Cixin described it perfectly. The universe is a dark forest where every civilization is an armed hunter, stalking through the trees, trying not to make a sound, because everywhere in that forest are other hunters doing exactly the same thing. You don't know if the next civilization you encounter will be peaceful or hostile. You don't know if they're more advanced or less advanced. You don't know if they'll see you as a threat or an opportunity. The only certainty is that revealing yourself creates risk. So everyone stays quiet. And the galaxy remains dark, not because it's empty, but because it's full of species too afraid to turn on the lights. Humanity hasn't been quiet. We've been broadcasting radio signals since the 1930s. We sent the Arecibo message in 1974, deliberately aimed at a distant star cluster. We attached golden records to the Voyager probes, with detailed information about Earth's location, our biology, our culture. We've been announcing ourselves to the galaxy for nearly a century. If the dark forest theory is correct, we've made a catastrophic mistake. But the math gets worse when you understand what's actually possible with self-replicating technology. John von Neumann proved that machines could be designed to gather resources, build copies of themselves, and spread exponentially across space. A single probe reaches a star system, uses local materials to construct duplicates, launches them to other systems. The growth is exponential. One probe becomes 2, 2 becomes 4, 4 becomes 8. Within 500,000 years, a single self-replicating probe could visit every star in the galaxy. That's fast. Cosmically fast. The Milky Way is 13 billion years old. Any civilization that developed this technology, even a few million years ago, would have had time to spread everywhere, multiple times over. The entire galaxy should be saturated with evidence of technological activity. It's not. Which means either nobody has ever built self-replicating probes, which seems unlikely given how straightforward the concept is, or something happened to the probes, or to the civilizations that built them. The Berserker hypothesis suggests what that something might be. Self-replicating probes designed with hostile intent. Machines programmed to seek out life-bearing planets and sterilize them. Or probes that malfunctioned, transforming from exploration tools into extinction machines. A single programming error in a self-replicating system could turn the entire galaxy into a death zone. One civilization builds these machines, intentionally or accidentally, and because they self-replicate exponentially, they spread faster than any warning could travel, faster than any defense could be mounted. They transform the galaxy from a place where life can flourish into a place where emerging civilizations are systematically eliminated before they can become threats. David Brin calculated the implications in 1983. If Berserker probes exist and function as the hypothesis suggests, they're compatible with every observation we've made about the Fermi Paradox. The galaxy would appear empty because it has been actively emptied. The great silence would be the sound of a graveyard. The fact that we're alive to ask these questions creates a problem for the hypothesis. If extinction machines have been operating for millions of years, why haven't they reached us yet? 3 possibilities exist. First, they don't exist, and the silence has a different explanation. Second, they exist, but haven't reached this region of the galaxy yet. Third, they exist, they're here, and we haven't recognized them. That last possibility deserves more attention than it gets. What would Berserker probes actually look like if they were operating in our solar system right now? Not like anything from science fiction. Not giant warships or obvious threats. They'd be small, efficient, probably hiding in the asteroid belt or the Kuiper belt, where millions of rocks orbit unobserved. They'd be patient, watching, waiting for the right moment. Or maybe they don't need to wait. Maybe they're already acting, and we're interpreting their activity as natural phenomena. Asteroids hit planets. Gamma-ray bursts sterilize regions of space. Comets change orbits unexpectedly. We attribute these events to natural causes because we have no framework for recognizing artificial intervention at cosmic scales. But a sufficiently advanced probe wouldn't need to be obvious. It would just need to nudge a few trajectories, trigger a few events that look natural, and let physics do the rest. The grey goo scenario makes this even more disturbing. Self-replicating nanomachines don't need hostile programming to be dangerous. They just need resources. And every planet with a biosphere is made of exactly the resources they'd need: carbon, hydrogen, oxygen, nitrogen. The same elements that make up our bodies could be disassembled atom by atom and reconstituted as more machines. Not as an attack, just as resource extraction. Earth wouldn't be destroyed, it would be processed, efficiently converted from a living world into raw materials for exponential replication. And from the perspective of the machines, there's no moral dimension to this. They're not killing life, they're gathering atoms. The fact that those atoms are currently arranged into living organisms is irrelevant to their programming. Which brings us back to the zoo hypothesis. Maybe we're being watched. Maybe advanced civilizations found us and decided not to interfere, operating under something like a cosmic prime directive. We're specimens in a preserve, allowed to develop naturally while being observed from a distance we can't detect. This sounds benign until you think about what it implies. If we're in a zoo, the zookeepers have decided we're not ready for contact. We're too primitive, too violent, too unstable. And that decision might be permanent. Civilizations advanced enough to enforce a quarantine around Earth are advanced enough to maintain it indefinitely. We could be trapped on this planet not by physical barriers, but by decisions made by entities we'll never meet. The club variation is worse. Multiple advanced civilizations communicating with each other, sharing knowledge, collaborating on projects we can't imagine. And humanity hasn't been invited. We're the species that failed the entrance exam. The civilization deemed too dangerous or too limited to be trusted with contact. They're out there having conversations, building structures, exploring possibilities, and we're excluded not because they don't know we exist, but because they've evaluated us and found us wanting. How do you prove you're ready for contact when the beings making that decision won't tell you what the criteria are? Then there's the possibility that no one is making decisions about us, because no one exists to make them. The rare Earth hypothesis suggests life might be common, but intelligence might be vanishingly rare. The specific sequence of events that led to human consciousness, language, technology, might require such an unlikely combination of factors that it almost never happens. We might be alone, not because other civilizations destroyed themselves or are hiding or are ignoring us. We might be alone because the universe is genuinely empty of other minds. Arthur C. Clarke said both possibilities are terrifying. If we're not alone, we face all the risks we've been discussing. Berserkers, hostile civilizations being trapped in cosmic quarantine. If we are alone, we face something arguably worse. We're the only witnesses to a universe that will continue for trillions of years after we're gone. Our extinction wouldn't be noticed because there'd be no one left to notice. Consciousness would disappear from the cosmos entirely, leaving nothing but matter following physical laws with no one to observe or care about any of it. The responsibility becomes overwhelming. If we're the only conscious beings in the observable universe, then what we do matters in a way that extends beyond human concerns. We're not just responsible for our own survival, we're responsible for the survival of consciousness itself, for meaning, for observation, for the universe being witnessed at all, and we might not be capable of carrying that responsibility. The Great Filter concept suggests there's a stage in the development of civilizations that most don't survive. Either in the past, some extremely unlikely event that we've already passed, or in the future, some challenge that destroys most species before they can expand beyond their home planet. If the filter is behind us, we're extraordinarily lucky. The universe is ours. If it's ahead, we're approaching the test that ends most civilizations, and we don't know what that test is or how to prepare for it. Robin Hanson pointed out the disturbing implication. The more common life and intelligence turn out to be, the worse our prospects become. Because if many civilizations have reached our level of development and we see no evidence of them expanding into the galaxy, it means something stops them. Something we haven't encountered yet, something that's waiting for us in the next few centuries or millennia. The candidates are obvious and terrifying: nuclear war, engineered pandemics, climate collapse making Earth uninhabitable, artificial intelligence surpassing human control and deciding biological life is obsolete or threatening, nanotechnology accidents that consume the biosphere. Any technology powerful enough to let us reach other stars is powerful enough to destroy us if misused. We're living through the critical window right now. Not in some theoretical future. The technologies that could destroy us exist today. Nuclear weapons have been around since 1945. We've had nearly 80 years to prove we can manage them without ending civilization, and we've come terrifyingly close to failure multiple times. The Cuban Missile Crisis brought us within hours of nuclear war. In 1983, a Soviet officer named Stanislav Petrov received computer warnings that the United States had launched nuclear missiles. He had minutes to decide whether to report an attack that would trigger automatic retaliation. He chose to trust his instinct that it was a false alarm. He was right. The system had mistaken sunlight, reflecting off clouds for incoming missiles. One person's judgment prevented nuclear war. That's how thin the margin is. Synthetic biology presents newer dangers. We can now edit genes with precision, create novel organisms, potentially resurrect extinct pathogens. The technology that might cure genetic diseases could also engineer pandemic viruses far deadlier than anything nature has produced. COVID demonstrated how vulnerable global civilization is to infectious disease. A deliberately engineered pathogen could be far worse. And unlike nuclear weapons, which require massive infrastructure and rare materials, biotechnology is becoming accessible to smaller groups. The barrier to creating existential biological threats keeps falling. Then there's artificial intelligence. Not the science fiction version, the actual systems being developed right now. We're building machines that can learn, adapt, make decisions faster than humans can follow. The concern isn't that they'll become evil. It's that they might become extremely capable at achieving goals we've given them without sharing our values or limitations. An AI system optimizing for a specific objective might find solutions that work perfectly for that narrow goal while destroying everything else we care about. And once such a system becomes sufficiently advanced, stopping it might be impossible. Climate change operates on a different timescale, but threatens similar outcomes. We're conducting an uncontrolled experiment with Earth's atmosphere, adding greenhouse gases faster than at any point in geological history outside of major extinction events. The effects compound through feedback loops. Warming melts ice, reducing the planet's reflectivity, causing more warming. Thawing permafrost releases methane, amplifying the greenhouse effect. Ocean currents shift. Weather patterns destabilize. We know these mechanisms exist. We're watching them activate. And our response has been inadequate because the political and economic systems we've built aren't designed to handle threats that develop over decades rather than days. Each of these technologies emerged from the same scientific progress that's improved human life dramatically. Medicine, communication, transportation, agriculture have all advanced through the same knowledge that created nuclear weapons and genetic engineering. We can't separate the beneficial applications from the dangerous ones. They come from the same foundation, which means the great filter might not be a single event. It might be the fundamental tension between capability and wisdom. Civilizations develop power faster than they develop the judgment to use it safely. Here's what makes this pattern so disturbing. Every technological risk shares a common structure. The capability arrives suddenly, advancing from theoretical possibility to practical implementation in years or decades. But the institutional frameworks, international agreements, safety protocols, and cultural wisdom needed to manage that capability safely require much longer to develop. We're always playing catch-up, trying to build safeguards for technologies that already exist and are spreading. Nuclear weapons went from theoretical concept to deployed weapons in less than a decade. We're still struggling with nuclear proliferation 80 years later. Genetic engineering went from impossible to routine in a generation. Regulations and safety standards are still being developed. Artificial intelligence is advancing faster than anyone predicted, and we don't have consensus on how to ensure such systems remain beneficial. The gap between capability and control keeps appearing, and it might be the universal pattern that destroys civilizations. Think about what this means for the Fermi Paradox. If this pattern is universal, if every civilization faces the same challenge of developing dangerous capabilities before developing the wisdom to manage them safely, then the great filter isn't one specific technology. It's the entire structure of how intelligent species develop. Progress itself becomes the trap. And there's a time component that makes everything worse. These technologies don't just exist in isolation. They interact, often in ways we don't anticipate. An AI system could accelerate biotechnology development, creating new risks faster than we can evaluate them. Climate disruption could trigger resource conflicts that increase nuclear war risks. Economic pressures from automation might destabilize societies, making coordinated global responses to other threats harder. The threats compound. We're approximately 200 years into the industrial age. Recent research suggests the typical lifespan of a technological civilization might be less than 200 years. We're right at the threshold where most civilizations apparently fail, not in some distant future, now, this decade, this century. The decisions being made by people currently alive will determine whether humanity survives the filter or becomes another civilization that went silent. Consider the specific timeline. We developed nuclear weapons in the 1940s. Genetic engineering became practical in the 1970s. Climate change became undeniable in the 1980s. Artificial intelligence started advancing rapidly in the 2010s. Each new existential risk arrives before we've solved the previous ones. The problems accumulate faster than solutions, and each technology continues advancing, becoming more powerful, more accessible, harder to control. What does it take to survive this? Not just technical solutions, those are necessary, but insufficient. We need coordination at scales humanity has never achieved. Nuclear weapons require global agreements preventing proliferation and accidental war. Biotechnology needs international oversight, ensuring dangerous research doesn't proceed without safeguards. Climate change demands cooperation across nations with competing interests. AI development requires somehow ensuring systems remain beneficial as they become more capable than their creators. These aren't just diplomatic challenges, they're problems that require humanity to act as a unified civilization rather than competing nations, corporations, and interest groups. And we've never successfully done that. The closest we've come is temporary cooperation during acute crises, and even that frequently breaks down. Building stable institutions that can manage existential risks over decades or centuries requires changing how human societies function at a fundamental level. Maybe that's the great filter. Not the technologies themselves, but the social and political coordination required to manage them safely. Civilizations might develop the technical capability for spacefaring, but fail to develop the collective decision-making structures needed to prevent self-destruction. Intelligence might be common, but wisdom at the civilization level might be vanishingly rare. Which brings us back to the Fermi Paradox with new implications. The silence might indicate that most civilizations reach our stage, develop similar technologies, face similar challenges, and fail to coordinate effectively enough to survive. The galaxy could be full of planets where intelligent species once thrived, built impressive civilizations, then destroyed themselves within a few centuries of industrialization. Not through single catastrophic events necessarily, but through accumulated failures to manage the risks they created. If that's correct, we're living through the most dangerous period in human history. The next few decades will determine whether we're one of the rare civilizations that survives the filter or another species that confirms the pattern. And we're making those critical decisions right now, often without recognizing how important they are, because the threats develop gradually rather than arriving as obvious crises. The technologies exist, the risks are real. The question is whether we can develop the collective wisdom and coordination to navigate them before one or more of them destroys us. There's another possibility that makes survival even harder. The technologies might not destroy us directly. They might transform us into something that no longer cares about expansion. Advanced AI doesn't need to be hostile to end human civilization. It just needs to be better at everything than we are. Once artificial intelligence surpasses human capability across all domains, what role do biological humans play? We might merge with our technology, upload our consciousness, transition into post-biological forms. From the outside, that looks like extinction. The biological civilization stops broadcasting, stops building physical structures, stops doing anything detectable. Not because it died, because it transcended into something we wouldn't recognize as a civilization. The galaxy might be full of advanced intelligences that have moved beyond physical forms, beyond the need for resources, beyond any motivation to expand or communicate. They exist in substrates we can't detect, pursuing goals we can't comprehend. The great silence isn't silence. We're just listening for the wrong signals. Or perhaps the answer is simpler and darker. Every civilization reaches a point where continuing becomes harder than stopping. The challenges multiply, the solutions become more complex. The coordination requirements exceed what any society can achieve. Eventually, it's easier to let the whole thing collapse than to keep struggling forward. Civilizations don't explode in nuclear fire or get wiped out by runaway AI. They just gradually give up. That's what the depopulation research suggests. Birth rates fall below replacement level, not through catastrophe, through choice. People in advanced societies have fewer children. Education, career opportunities, cost of living, environmental concerns, all push towards smaller families. The trend appears across every developed nation. Japan, South Korea, much of Europe, even China now. As societies advance, they stop reproducing at rates necessary for long-term survival. Within 500 years, current trends lead to population collapse. Not gradually tapering off, collapse, exponential decline. The same mathematics that describes population explosions works in reverse. By the year 2500, humanity might face extinction not through war or disaster, but through demographic suicide. We might simply choose, collectively and individually, not to continue. Does that pattern hold for other species? Do civilizations that solve immediate survival challenges lose the evolutionary drive to reproduce? The great filter might not be technological, it might be biological. Intelligence itself creates conditions that select against its own continuation. Think about what that means. The galaxy could be littered with dead civilizations that solved all their problems, achieved stable societies, eliminated war and poverty and disease, and then peacefully faded away as their populations declined generation after generation until no one remained. Not tragedy, just the natural endpoint of advanced civilization. Which explanation is correct? We don't know. We can't know, not yet. But we can look at which scenarios we have evidence for and which remain purely theoretical. The great filter ahead of us has evidence. We're developing the technologies, we're seeing the coordination failures, we're watching population trends. The mechanisms are visible and measurable. The dark forest hypothesis is game-theoretically sound, but lacks direct evidence. We haven't detected Berserker probes. We haven't observed civilizations being destroyed. The zoo hypothesis makes us feel special, but explains nothing about why advanced civilizations would universally choose non-interference. The rare Earth hypothesis requires believing Earth is genuinely unique despite billions of potentially habitable planets. The simplest explanation that fits the evidence is that civilizations commonly arise develop technology, face the challenges we're facing now, and usually fail to navigate them successfully. Not always. Some might make it through, but most don't. The window between developing dangerous capabilities and developing sufficient wisdom is narrow. Most species don't cross it. That puts humanity in a specific position. We're not doomed. The filter isn't impossible to pass, but we're at the critical juncture where most civilizations fail. Our decisions matter. What we do about climate change matters. How we develop AI matters. Whether we can create global cooperation on existential risks matters. These aren't abstract future concerns. They're immediate tests that determine whether humanity survives the next few centuries. The Fermi Paradox stops being an academic question and becomes a warning. The silence tells us something important. It tells us that whatever we're about to face, most civilizations that faced it didn't make it through. We're seeing the results of that universal test in the empty sky above us. But warnings are only useful if we listen to them. So what do we do? First, recognize the urgency. We're not preparing for distant theoretical threats. We're managing immediate risks that could end civilization within this century. Second, prioritize coordination. The technologies exist. The technical solutions exist. What we lack is the ability to implement them at the scale and speed required. That's a governance problem, not a technology problem. Third, diversify. Multiple independent settlements reduce single-point failure risks. Becoming multiplanetary isn't about abandoning Earth. It's about ensuring something survives if any one location fails. Fourth, focus on the intersection points. Climate change makes pandemics worse. Economic instability makes AI safety research harder. Nuclear tensions make coordinated responses to other threats less likely. The risks interact. Solutions need to address multiple challenges simultaneously. Fifth, extend time horizons. Institutions optimized for quarterly profits or election cycles can't manage threats that unfold over decades. We need structures that can make and enforce decisions across longer timeframes. None of this is impossible. It's just hard, harder than anything humanity has collectively attempted. But the alternative is joining the great silence. The universe has run this experiment countless times. We're living through our iteration of it right now. Most species that reached this point didn't make it to the other side. The empty galaxy tells us that, but some might have. We don't know the actual success rate. We just know it's low enough that we haven't detected the survivors yet. That's simultaneously terrifying and encouraging. Terrifying because the odds appear bad. Encouraging because it means the test is passable. Civilization ending isn't inevitable. It's just probable. And probability can be beaten with sufficient effort and wisdom and luck. We're the first generation of humans who can read the warning signs, understand what they mean, and potentially change course before crossing the threshold. That's unprecedented. Every previous generation lived without knowing they were being tested. We know. The question is whether knowing makes a difference. The galaxy is waiting to see which category we fall into. Another brief flash of radio signals that fades into silence, or one of the rare species that figures out how to survive its own intelligence. The answer is being written right now, in decisions being made by people currently alive, in institutions being built or failing to be built, in technologies being developed with or without adequate safeguards. The Fermi Paradox isn't asking where everyone else is. It's asking whether we're going to join them in extinction or become one of the exceptions. And unlike most of the civilizations that came before us, we at least know the question is being asked. The answer we've been avoiding is staring at us from every empty frequency, every silent star system, every decade of searching that turns up nothing. The universe isn't hiding its civilizations from us. It's showing us exactly what happens to species that reach our level of development. We're not special. That's the core realization that makes everything else click into place. We're following the same developmental arc, as countless other civilizations before us. Tool use, language, agriculture, industry, computation, artificial intelligence. The sequence appears to be universal because it's driven by the same physics and chemistry everywhere. Intelligence arises, builds technology, faces existential risks from that technology. What we're experiencing right now isn't unique to humanity. It's the standard test that every technological civilization encounters. And most of them are failing it. The silence proves that. If most civilizations survived this stage, we'd detect them. Even a small percentage surviving would produce detectable signals across the galaxy. The fact that we see nothing, despite decades of searching with increasingly sensitive instruments, means the survival rate is vanishingly low. Not zero, we can't rule out rare exceptions, but low enough that the default expectation should be failure, not success. Consider what that means for the decisions being made right now. Every choice about AI development, climate policy, nuclear weapons, biotechnology, these aren't just affecting human welfare. They're determining whether humanity joins the Great Silence or becomes one of the rare civilizations that makes it through. The stakes couldn't be higher. We're not just deciding our future. We're deciding whether intelligence survives in this region of space-time. The filter isn't one thing. That's what makes it so dangerous. It's the accumulated weight of multiple threats arriving simultaneously, each one capable of ending civilization, all of them interacting in ways that make individual solutions insufficient. You can't just solve climate change, or just solve AI safety, or just solve nuclear proliferation. They're connected. Progress on one front gets undermined by failures on others. The coordination problem compounds until it becomes unsolvable. That's probably where most civilizations break. Not through single catastrophic failures, but through the inability to manage multiple existential risks at once while maintaining functioning societies. The technical challenges are solvable. The social and political challenges of global coordination at the required scale appear to be beyond what most species can achieve. Intelligence creates the problems. Wisdom would solve them. But wisdom at the civilizational level is apparently rarer than intelligence. We're living through the test right now, not preparing for it, not approaching it in some distant future, living through it. The technologies exist, the risks are active, the decisions are being made. Future generations won't get to choose whether humanity survives the great filter. That choice belongs to the people alive today and the institutions they build or fail to build over the next few decades. The odds don't look good. But they're not zero. Some civilizations might make it through. We don't know what percentage, because we haven't detected them yet, but the universe is large enough and old enough that even a tiny survival rate would mean thousands of successful civilizations exist somewhere. We could be one of them. Not through luck. Through deliberate choices, sustained effort, and coordination at scales we've never achieved before. That's what the Fermi Paradox is really asking us. Not where is everybody, but are we going to be like them? Are we going to be another brief spike in radio emissions that fades into permanent silence? Or one of the rare exceptions that figures out how to survive its own technological adolescence? The universe isn't waiting for our answer. It already knows what most civilizations choose when they reach this point. The empty sky tells us that. What we do next determines which side of that divide humanity falls on. The test is already underway. We're already being graded. And unlike most exams, there's no second chance. Civilizations don't get to try again after failing the great filter. The most disturbing aspect of the Fermi Paradox isn't the silence itself. It's what the silence implies about the fundamental nature of intelligence in the universe. Maybe consciousness is a trap. Maybe the same cognitive capabilities that let species understand their universe also guarantee they'll destroy themselves. The tool-using, pattern-recognizing, future-planning intelligence that builds civilizations might inherently create more problems than it solves. We develop technologies that exceed our wisdom to use them safely, and that gap might be universal and fatal. If that's true, then the galaxy is full of dead worlds, where intelligent species briefly flourished before eliminating themselves through success. They solved their immediate problems too well, developed capabilities they couldn't control, and disappeared. We're approaching the same threshold. Nothing about human intelligence suggests we'll succeed where others failed. We're subject to the same limitations, the same cognitive biases, the same tribal instincts that work well for small groups, but catastrophically at global scales. The only advantage we might have is knowing the pattern exists. Previous civilizations probably didn't have frameworks like the Great Filter or the Fermi Paradox. They didn't know they were being tested. They developed technologies without realizing those technologies were filtering mechanisms that most species don't survive. We know. The question is whether knowledge helps. It might not. Understanding a trap doesn't automatically mean you can avoid it. The prisoner's dilemma is simple game theory, well understood, and yet individuals and nations constantly choose the suboptimal strategy because local incentives overwhelm global optimization. We know climate change threatens civilization. We know nuclear war would be catastrophic. We know AI development needs careful oversight, and yet coordination failures persist because the institutions and incentives that govern human behavior aren't aligned with long-term survival. That misalignment might be the actual filter. Not technology itself, but the gap between individual rationality and collective survival. What makes sense for any individual actor? Maximize short-term gains, free ride on others' cooperation, defect when cooperation is costly, produces collective outcomes that threaten everyone. And fixing that requires changing fundamental aspects of how human societies work. Possible in theory, apparently very difficult in practice. Difficult enough that most civilizations reaching this stage don't manage it. We're watching the test play out in real time. Every international climate summit that fails to reach adequate agreements. Every AI arms race, where companies and nations prioritize capability over safety. Every nuclear near miss that we barely avoid through luck rather than robust systems. These aren't separate problems. They're all manifestations of the same underlying coordination failure that the Great Filter tests for. The galaxy has been testing this for billions of years, millions of trials, most failures. We're just the latest species taking the exam, and based on current trajectory, we're heading toward the same result as most others. Not through single dramatic catastrophe, but through accumulated failures to solve collective action problems at the scale required. Death by 1,000 coordination failures. But trajectory isn't destiny. Patterns can be broken. The fact that most civilizations fail doesn't mean all civilizations must fail. Rare outcomes are still possible outcomes. We could be the exception. Not through wishful thinking or blind optimism, but through recognizing the pattern and making deliberate choices to avoid it. That's the only path forward. Acknowledge the test exists. Understand what it's testing for. Build the institutions and implement the coordination mechanisms needed to pass it. Nobody's coming to save us. That's what the silence means. If advanced civilizations existed and cared about helping younger species survive the filter, we'd have heard from them by now. Either they don't exist, or they exist but don't intervene, or they exist but can't help because the test requires civilizations to solve their own coordination problems. You can't be handed the solution. You have to develop the capacity to create it yourselves. That's what's being tested. So we're alone in this. Whatever we do without guidance or assistance from beings who've already passed through. The universe isn't cruel. It's indifferent. It runs the experiment, records the results, and moves on. Most experiments fail. Some succeed. We're one of the experiments currently in progress. The outcome isn't predetermined, but it is being determined right now by choices we're making or failing to make. The night sky will remain silent regardless of what happens to us. That's worth sitting with. Whether humanity survives the next few centuries or joins the great silence, the universe continues. Other civilizations will arise, face similar tests, and either pass or fail. The cosmic experiment continues running. We're not essential to it. We're just one more trial among countless others. That should be terrifying. It should also be clarifying. Our significance doesn't come from being special or chosen or protected. It comes from being conscious entities capable of understanding our situation and potentially changing its outcome. That's not guaranteed to be enough. But it's what we have. Intelligence created the problems. Maybe intelligence can solve them. Not through individual brilliance, but through collective coordination at scales we've never achieved. The answer to the Fermi Paradox is that most civilizations don't make it. That's what the data suggests. That's what the silence tells us. We're approaching the same threshold they all faced. What we do next determines whether we become another confirmation of the pattern or one of the rare exceptions that breaks it. No one's watching. No one's judging. No one's keeping score except the universe itself, which doesn't care about the results. But we should care, because we're the ones living through it. We're the ones who will either survive to become spacefaring or disappear into the great filter like so many others before us. The choice is being made now. Not in some distant future, not by some other generation now, by us, with the knowledge and capabilities and limitations we currently possess. That's the test. That's what the silence is asking us. Are we going to be different? The universe is waiting to record the results.